We see now how the fundamental theorem of arithmetic helps us to find the HCF of two numbers and also the LCM of two numbers. Of course, the HCF can be found by using the division algorithm. Now here we are using the fundamental theorem of arithmetic to find both the HCF and the LCM, highest common factor and the lowest common multiple. Now we can see here highest common factor and lowest common multiple LCM of two numbers A and B. Now we define HCF and LCM by using prime factor theorem, that is fundamental theorem of arithmetic. Now HCF of AB is equal to the product of smallest power of each common prime factors in A and B. And LCM of AB equal to product of greatest power of each prime factor involved in A and B. Now let us consider, for example, A is equal to 24 and B is equal to 36. Now we can see here A equal to 24, that is prime factorization. We can use that theorem and write as the product of prime factors of 24. 2 into 2 into 2 into 2 into 3, which I can write down in terms of powers of primes. 2 raised to 3 into 3 raised to 1. And B equal to 36, which I can write down, that is 2 into 2 into 3 into 3, that is 4 into 9, that is 36, which you can write down as the prime factor, powers of prime factor, that is 2 into 3 raised to 2. By the definition made above, HCF of 24 and 36 is equal to highest power of 2, lowest power of 2. Lowest power here in the both factorization 2 raised to 2, and the lowest power of other factor, that is 3 and 3 are in both factors of A and B, and the lowest one is 3 raised to 1, that is 4 into 3, that is 12. And similarly, LCM by the definition of LCM of AB made above, 24 and 36 equal to the greatest power of each prime. Greatest power is here 2 raised to 3, and greatest power is here 3 raised to 2, that is 8 into 9, that is 72. Here. In this way, we can use the fundamental theorem of arithmetic and find the HCF and also LCM of the numbers. Let us consider another example here, that is A equal to 12 and B is equal to 28. Now here A equal to 12, that can be written as 2 raised to 2 into 3, that is 4 into 3, 12. And B is equal to 2 raised to 2 into 7, 4 into 7, 28. Now LCM, therefore HCF is equal to the least power of the numbers involved in both the numbers. Here least is 2 raised to 2. 3 is not in B and 7 is not in A, that is 4. And LCM equal to highest power of the numbers involved, factors involved in the both this. That is 2 raised to 2 into 3 raised to 1 into 7 raised to 1. That is, uh, what is that? 2 raised to 2, 4, 4 into 3, 12, 84. Now observe that HCF of 12 and 28 into LCM of 12 and 28 is equal to 4 into 84, that is exactly 336, and this also be written as uh, 12 into 28, the value, that is A and B. From this uh, observation we can make some general statement here. From the above example, one can see that for any two positive integers A and B, HCF of AB into LCM of AB equal to the product of those two numbers involved in that. And from this, if we know HCF of AB, then we can find the LCM of AB and vice versa. Now we can see, for example, 96 and 404. That is LCM of HCF. So, okay, now first write down HCF. Before that, we can write down the factorization of 96 equal to 2 raised to 5 into 3 and B equal to 404 equal to 2 raised to 2 into 101. 101 is a prime, and therefore HCF of 96 and 404 equal to the least power of the factors involved in it. The least power is here 2 raised to 2, and 3 is not there, and 1 is not here in here, and therefore this is going to be 2 raised to 2, that is 4. Then what about by using the formula which you have already written? Therefore, by the formula LCM equal to of 96 and 404 equal to uh, 96 into 404 divided by HCF of 96 and 404, and that equal to we can see here uh, above one is what is that, 96 into this divided by 4, 96 into 404 divided by 4, and that equal to 96 into 101, that is 9696. This is easy. If you know LCM, then you can find out the HCF. If you know HCF, you can find out the LCM. One is sufficient to find out the LCM or HCF. What about LCM of three numbers? Now let us consider uh, this as now we can see A is equal to the same example which I am going to take 6, B is equal to 72, and C is equal to 120, and therefore I can write down this as 6 is equal to 2 into 3 and 72 equal to 72 equal to, sorry, 72 equal to 2 raised to 3 into 3 raised to 2 and 120 equal to 2 raised to 3 into 3 into 5. Now, by the definition of HCF, HCF of 672 and 120, the least power of prime factors involved in the three numbers. 2 is the least and 3 is the least, that is 2 into 3, that is 6. And the LCM of 672 and 120, that is greatest power, that is 2 raised to 3 and 3 raised to 2 and 5, that equal to what is that? 360. 360. Now we can observe this one. Observe HCF of 672 and 120 into LCM of 672 and 120 equal to, by the computation which we have already made, is equal to 6 into 360, and that is going to be 6 into 360, that is 6 into 360 is equal to 200, 200, sorry, 2160. But 6 into 72 into 120 is equal to 551,840. This shows that HCF of ABC into LCM of ABC need not be equal to A into B into C. However, HCF of ABC is equal to HCF of the HCF of AB and C, and LCM of ABC is equal to LCM of AB into C. Now you can see, for example, the same example you can say HCF of 620, 672 is equal to 6, and HCF of 120 equal to 30, and therefore the HCF of 6 and 120, sorry, this is and therefore HCF of 672 and 120 equal to HCF of 672 and 120. Again, that is going to be HCF of 672 is equal to 6 and 120. That is again as 6. And therefore, similarly, we can prove this also. LCM of AB equal to LCM of AB and C.